Today we will see the practical use of pointers and references in C++. So far we saw how to store a single value in a variable. We also looked at how to store a list of values in a fixed size array. Now let's see where this value is stored. That is, what is the memory address at which this variable is stored, and what is the value that is stored in that memory location. To answer these questions, we will use pointers and references. So let's begin by looking at line 23. In line 23, I'm declaring an integer a, which is initialized to value equal to 10. Now, to access the memory address in which this variable a is stored, we can use the ampersand operator. So there are two new operators which we will look at today. First is ampersand and second is a star operator. The ampersand operator is useful to find out what is the memory location at which a particular variable is stored, and star has multiple meanings. So again, both ampersand and star has different meanings depending on the context where we use it. We will look at the different use cases in a while. So first let's look at line 24, in which on the right hand side I'm writing ampersand a. What this means is I want to access the memory address in which this variable a is stored and save it in this new variable address underscore of underscore a. Now this variable address underscore of underscore a is of type int star. So here star refers to that this variable is of type pointer, and it's pointing to a memory that holds an integer. So to declare a pointer, you will write data type followed by star, then followed by the variable name. So for example, int star address underscore of underscore a will make this variable address underscore of underscore a of type pointer, and it's initialized with a memory address. So to get the memory address of a variable, we can use the ampersand operator. So ampersand a on the right hand side of an assignment expression will access the memory address of this variable and saves it in address underscore of underscore a. So now when we execute this code and print this variable address underscore of underscore a, we should see the memory address that is holding the variable a. So let's look at the output. Notice this is the memory address. It's an hexadecimal. So let's copy this memory address, and now we'll go to the debug, Windows, and memory. So similar to watch, we have this window in Visual Studio where we can provide a memory address and look at the value stored at that particular memory address. So here I'm copying the address at which the variable a is stored. So when I hit enter, we should be able to look at this address. So this is the address, and these are the four values that are stored at this particular address. So since int is 32 bytes, we have 4 bytes here. So int is 32 bit, therefore we have 4 bytes. Each byte is 8 bit. The first byte is 10, which is the value that was initialized, and the rest of them are the most significant bytes, which are all zeros. So the number is read from right to left, so the number is 00010. Now let's see what happens when we write a statement like this. In this statement, I'm writing star address underscore of underscore a is equal to 20. In the previous case, the star was used to represent that this variable is of type pointer. Notice that there is a space between star and the variable name. Now without a space, this variable acts as a dereferencing operator. So here we want to dereference the variable address underscore of underscore a. That is, we want to access the value that is stored in this memory address held in this variable address underscore of underscore a, and then modify that value by overwriting it with 20. So first, this will access the memory address in which the variable a is saved, dereferences that address, and then overwrites it with value equal to 20. So now let's print a after this line 34 and check what will be the value of a. The question is whether will it be still equal to 10 or whether it changes to 20. Okay, so notice a is equal to 20 after this call, and also in the memory window we see that the address has now value equal to 20. Before it was 10. Now similar to arithmetic that we do with regular variables, for example here I want to multiply a with 10 and then store the result back in a. We can do this by using pointers. So address underscore of underscore a again holds the pointer to the variable a. We can dereference it with the star operator. This gives us this is equivalent to just writing a. On the right hand side again we will replace a with star address underscore of underscore a, multiply that with 10, and the result will be that the current value of a is 20, so we multiply 10, so the value should be 200, and 200 should be written back to this particular memory location. So let's continue. Now let's print address underscore of underscore a, first to check whether the address gets modified in this arithmetic. Here notice we are not changing the address, we are changing the value that is stored within the address since we are dereferencing it. So first let's make sure the address is the same. Okay, so notice address is the same as before. We have a bunch of zeros followed by 6, AB 777 F464, so which is the same as before. Now however, the value stored in that address location has changed from 20 to 200. So star followed by a variable, the variable if it's of type pointer will dereference the pointer and provides you with the value stored at that memory location. Next let's see what a reference is. So far we saw how to access the memory address of a variable using a pointer. Now we can also do this with a reference. So for example in line 52 I'm declaring a new integer a2 initialized to value equal to 30. And in line 53, I'm taking a reference to it. Now notice again I'm using the ampersand operator. So previously ampersand was on the right hand side, wherein we were querying what is the address of a given variable, what is the address of the memory location in which the variable is stored. Now on the left hand side, when ampersand is next to a data type, it means that the variable is a reference to some other variable. So here a underscore ref refers to a, which is of type integer. Therefore, our a underscore reference is also of type integer, and the ampersand here represents that this variable is a reference. Now, the difference between a reference and a pointer is that a reference always points to the same variable. That is, once it is initialized, a reference cannot point to a new variable. However, a pointer, even after it being initialized to a variable, it can point to some other variable at a later time. So we will look at a couple of examples shortly. First, let's look at what is the address of a underscore ref. So again, I'm using ampersand operator to query the address. And then let's compare it with the address of a. So since a underscore ref is a reference to a, both of these should point to the same memory address. So let's verify that by executing this code. Okay, so notice both the address, both the variables are pointing to the same memory address. So again, this says that reference can be used to hold the pointer to a variable, but once we initialize it, we can't modify it. So let's look at what that means in the next line. Here in line 55, I'm writing a underscore ref is equal to a2. Now this can be interpreted as that we want to change the reference of in which we want to change the variable to which a underscore ref is referring to a2, or this could also mean that we want to store the value that is in a2 in the memory location a underscore ref is pointing to. So let's see which one is the correct interpretation. So let's execute the code. Let's print the value of a and then print the value of a underscore ref, or we are printing the address of a underscore ref. So suppose this assignment operation is making a underscore ref point to a2, ampersand a underscore ref should be different, right? Now before it was pointing to a, if this makes it to point to a2, A2 has a different memory address, so A underscore ref should also be having a different memory address. However, if it's the same, then the value of A should be equal to value of A2, right? Since we are writing A2 is equal to A underscore ref is pointing to A, we are indirectly modifying the content of the variable A via the reference. So let's see what is the output. Okay, so notice A was previously 200, now it's changed to 30, which is also the value of A2, right? A2 was initialized to 30. So this statement here is not modifying the reference. That is, A underscore ref is still pointing to A, and this equation here, this assignment operation here, is changing the value of A via A underscore reference. So therefore, when we print the next line, which is the address of A underscore ref, it should be the same as before. And that's the case. So again, references refer to a variable that is initialized with. You cannot change, or you cannot make a reference to point to a new variable. However, you can do this with pointers. So now let's look at how to do this with pointers.